Hey guys, today I'm super excited to show you a tool that I've been working on. Everything that I'm about to show you is available for download for free from my GitHub. My goal with this tool is to help people who are new to the networking industry start to learn things like the basics of packet flow through different types of network devices, the fundamentals of network troubleshooting, and an entry level into network automation using things like Python and shell scripts. This tool covers all of that, as well as options to automatically stand up a virtual networking environment complete with switches, firewalls, and routers with predefined configuration files. Once the lab is stood up, this tool goes in and introduces random faults to each node within the network. It's then up to you as the network administrator to dig yourself out of it and get the network back up and running. I'll be using this tool in future videos as I start to show the fundamentals of network troubleshooting and how I would approach different problems that are reported by users. As you go through these different lab environments, if you become frustrated or run into a wall where you're unable to figure out how to get the network back up and running, no problem. The tool also has a reset to default command that will take the broken lab environment and reset it back to our default state. If you're coming to this video after watching my other how-to guides on manually installing and standing up Proxmox and EVNG, I will be posting a separate video which will show you how to install this tool manually in those environments. If you're just now joining us and you plan to stand up your EVNG lab using the automated method that I'm about to show you, I have tested this in both Proxmox and VMware ESXi. This should also work if you decide to stand up EVNG bare metal on your server. So that takes us to the requirements. You will need a server here that is at least 4 core and 16 gigs of RAM. Ideally, you would like to have up to 8 core and 16 or 32 gigs of RAM. If you're standing up in Proxmox and you need help, you'll find a playlist on my channel that's titled Building a Virtual Networking Lab Step by Step, and that will have everything you need to get EVNG up and running. If you plan to install this on VMware ESXi, one tip I can give you is that you need to enable promiscuous mode on the virtual switch that connects to the EVNG host. In both ESXi and Proxmox, I do recommend enabling host virtualization, which passes through the CPU resources directly to the EVNG host. If you do not have this enabled, you will more than likely run into issues getting the firewall nodes up and running. When you click start, they simply won't. So enabling host pass-through will get those up and running for you. All right, now that we've got that out of the way, let's get started on how to download and set up this self-breaking network tool. The first thing we're gonna do here is download 2 separate files. One is the template for our lab environment. This is a quick look of the topology, which is the same topology that we manually built in my last video. The only difference here is that we have added an Ubuntu host in the Enterprise Branch Office LAN, which has my GitHub project pre-installed. The second file that we'll be downloading includes the disk images and operating systems for all of these nodes that you see here outside of the virtual PCs, as those operating systems are pre-installed in EVNG. You will end up downloading these 2 files through the mega.nz link, which is in the pinned comment, but you will also be able to find this link within the GitHub project that is also included in the pinned comment. You can select this checkbox to download both, and then simply click the download button. Once the download completes, you will have 2 separate files, the lab1 template.unl.zip and then labsetup.zip. This labsetup.zip includes the images and disk files I mentioned, while this is the template that gets uploaded directly into EVNG. At this point, it is assumed that EVNG is already installed and up and running. If not, go ahead and do that first. And if you need help, I have multiple step-by-step tutorials on how to do this. We will need the management IP of our EVNG host, so in my case, it's 172.16.16.228. I will then need to find the files that I have downloaded. I can do this by navigating to the directory where my downloads are and running the command scp labsetup.zip to root at my management IP address of my EVNG host, and then enter. I'll be prompted for my EVNG root password, which I will have set up during the install process. And this will take care of copying labsetup.zip into the home directory of my EVNG host. Once the copy completes, we need to SSH into our EVNG host. It will be SSH root at our management IP address. And then we will enter our root password that we set up during that initial install phase. And this lands us in the root home directory. If we run an ls-la, we will see the file that we copied over, labsetup.zip. First thing we will do is unzip this file. So we'll run the command unzip space labsetup.zip. And once that is done, we should see that we have a lab setup directory here. We will then execute the setup script that's in that lab setup directory. We do that by running the command /lab setup /setup.sh. This will move the virtual disks and images into their respective directories, as well as generate our license key for our Cisco Layer 2 and Layer 3 devices. We will then navigate to our Eve management IP in our browser. The username here is admin, and unless you have changed it, the default password is Eve, EVE. From here, we will need to import the template that we downloaded as well. So we'll click the import button, and then we will import lab1template.unl.zip. This is the smaller of the two files. We have to click the upload button here, and then we will see our template listed as available. So I can click on this and then click open, and this will open our lab environment, and we will see all of our nodes here. I can simply drag across all of these nodes, right click on one and say start selected. It will take a little bit for each node to boot up, but I can go ahead and console into each of them. I can do this by left clicking on each node and opening the console windows. At this point, I have console connectivity to my Cisco switch, as well as my two different service provider routers, and my client side and application side virtual PCs. I also see that my two firewalls are up and running, and I have access to my Ubuntu automation host. My Ubuntu automation host is what controls the self-breaking aspect of this lab environment. I can log into this host using the credentials user, and password is test123 with a capital T. If this is my first time logging in, I'm going to set up the tool that I've built. I will do this by running the command sudo // uproot, and then I can tab my way through this. So uproot labs, lab1, and then setup.sh. Again, I'll put in my password, test123 with a capital T. And this will go through and install any dependencies we need, as well as set up the network interfaces and different definitions that are needed to connect to the different nodes. I will be asked for the branch pfSense management IP, as well as the application side pfSense management IP. I can get these from the consoles of the two nodes here. So I see this listed as my branch firewall. My management IP will be received from my home network. So in my case, it's 172.16.16.34. I will input that here. And then the password is going to be uproot123, unless you have manually set this lab up, and in which case it'll be whatever value you have set. My application side firewall, which I see here, the management IP address is 172.16.16.35. And again, the default password here is uproot123, unless you've changed this. It will go through and set up the REST API interface on both nodes, and then it will ask if you want to create first-time backups. If this is the first time running the setup script, you want to select yes and press enter, and then we will just wait for the script to complete. If we come into our virtual PCs, we can run the command DHCP on both of them, and these will go ahead and pull a IP address from the DHCP server that's running on our two firewalls. And at this point, I can ping end to end, so I could run the command ping 3.3.3.2, which is the WAN interface of my application firewall. That then gets forwarded from the WAN interface of my application firewall to the virtual PC that's running behind it, which is our VPC7 here. All right, now to the fun part. I can come into my automation host here and I can run the command uproot lab1, which is our lab environment, -h, and this will show me the commands that are available here. So if I run uproot lab1 -all, this will reconfigure every node in our path, including our switches, routers, and firewalls. If I only want to reconfigure one of those node types, I can simply specify -s, -r, or -f, depending on the node that I want to select here. I'm going to run the command uproot lab1 -a to reconfigure everything. This will start off by logging into our SP router 2 here, and we can see from the command line that there was configuration changed on SP router 2. It then navigates into SP router 1. Again, we see that there was some sort of config change here. Our firewalls were then reconfigured via API. And then lastly, our switch will have some configuration introduced as well. If I come back into my virtual PC and run the ping command, which was previously working, I see that I'm no longer getting responses. Matter of fact, if I do a show IP all, I can see my gateway is 192.168.100.1, and I can no longer even reach my gateway. It is then up to me as the network admin to come in here and figure out why things are not working properly. If you need some hints, you will see in the command line what type of changes were introduced here. And if you're unable to figure out how to fix it, you can come back in here and run the command uproot lab1 -d to reset things back to default settings. This will restore every node back to the default configuration, which we took a backup of during the initial lab setup script. This process will take a few minutes as the firewalls need to reboot, and we have to wait for the firewalls to fully come back up before we can reset some of the Cisco nodes. There are anywhere between 2 and 4 fault types for each of the nodes within the network, so switches, routers, and firewalls. And the idea is that this will result in different combinations each time you run this tool, so that you're not having to fix the same exact fault on every node in the network every single time. If you have ideas on additional fault types that we should include in this lab environment, you can come into my GitHub repo, navigate to Issues, and then open a new issue and drop your suggestion here. If I end up building this fault type, you'll get a notification since I'll close this issue, and then users can take advantage of the updates that were made by coming into their automation host and running the command uproot update. And this will go ahead and download the latest version that's available for your host. Be sure to like and subscribe to my channel, as well as star and follow my GitHub repo so that you can keep up with new lab exercises and updates to the tool as it is developed. Thanks for watching.